Okay, so we're going to talk about domain of functions. And so we're going to look at some examples. So the first example is f of x equals x squared plus 3x minus 4. Now this is a polynomial because it's got a integer, non-negative integer coefficients, and so even this is a non-negative integer coefficient because x to the 0 is 1, so we don't see it. But so when we have a polynomial, its domain is all real numbers. Okay. Remember, domain are the values that we're allowed to put in, and we get something out. So I can put any number in. I can take any real number and square it. I can take any real number times 3 and add it to the x squared, and I can subtract 4. So any number is allowed to be put into a polynomial. So anytime I have a polynomial, its domain is all real numbers. Here's an example of something that's not a polynomial. This is called a rational function. We've seen these before. And the domain of a rational function is all the numbers except where the denominator is 0. So I'll write that down. All numbers except where the denominator is 0. So as we look here, we have a denominator, and it is 0 at 2/3. So we take that denominator, set it equal to 0, and we get x equals 2/3. So that's when the denominator is 0. Denominator is 0 at x equals 2/3. Don't do that. Okay? So x can't be 2/3 because that's when the denominator is 0. So our domain is all the numbers except that. So as we write it as an interval, it's minus infinity up to 2/3 and then 2/3 beyond. So when we look at a real number line, we're going to remove the point 2/3, so we put an open circle there, but we have everything else. So to the left of 2/3 is minus infinity up to 2/3, and then from here it's 2/3 on, but because we're not including 2/3, we use the rounded parenthesis, not the other one. Okay, so that's our domain. Let's look at some other examples. Here we have a rational function that, well, we have a function that's a difference of rational functions. 2x over 5x minus 2 minus 3 over x plus 6. Now, if all we're asking is what is the domain, this can't be 0. The 5x minus 2 can't be 0. And this cannot equal 0 as well. So if I have 0 here, then what's going to happen is I have a number divided by 0, which is undefined. So I have an undefined number minus a defined number, which is undefined. So this part can't be 0, and this part can't be 0. Now they're not going to be 0 at the same time, so they can't be 0 at either time. So we look at each denominator separately. So when we're asking for domain, we're not asking you to make one rational function. What we're doing is asking you to determine what values cannot go into the function. So here I get x equals 2/3 or 2/5, and so when x is equal to 2/5, this denominator is 0, which is bad. So don't do that. Over here we have x plus 6 equals 0. So what we're asking is, when does the denominator equal to 0? And the denominator is equal to 0 and x is equal to minus 6. So we don't want that. We don't want the denominator to be 0, so don't pick that. Alright, so now we can think of this as a number line. We have minus 6 and 2/5. So I can't pick minus 6. I use an open circle to remove the value minus 6. I can't use positive 2/5, so I use an open circle to remove 2/5. But I want all the numbers less than minus 6. I want all the numbers between minus 6 and 2/5, and all the numbers bigger than 2/5. So this interval, less than minus 6, I can write as minus infinity up to minus 6. Between, minus 6 to 2/5, and then bigger than 2/5 is 2/5 to infinity. I can't include minus 6, so rounded parenthesis, rounded parenthesis. I can't include 2/5, so rounded parenthesis, rounded parenthesis. So finally, I can write my domain. We'll put it right here in the middle of the screen. Minus infinity up to minus 6, union with minus 6 up to 2/5, union with 2/5 to positive infinity. So this is all of the values, all the real numbers, except where the two denominators are equal to 0. Alright, one more example. And this is a function that's it doesn't really meet the criteria for rational function because the denominator is not a polynomial. The denominator is another rational function. So, but what is the domain here? So we actually have two denominators. This is one denominator. So it can't be 0. We have another denominator. This is a rational function, and this is its denominator. So x minus 1 is also a denominator. So it can't equal 0 either. So if we look at x minus 1 equals 0, we get plus 1. So x equals 1. When x equals 1, I have 4 over 0, which I can't have, so x can't be 1. Now I need to look at this thing. When is 4 over x minus 1 minus 3, when is that equal to 0? So I'm going to start off by adding 3 to both sides. This is one of those linear functions that looks a little different. See, we got that denominator in the bottom. So think back to before the test when we had problems that looked like this in this section on solving linear equations. And we're going to cancel the denominator. And you can also use cross multiplication. Now we're going to distribute. We're going to add 3 to both sides. So I get 3x equals 7. So divide both sides by 3. And I get x equals 7/3. So when x is equal to 7/3, this is equal to 0, and then I'm dividing 2 by 0, which, remember, I'm not allowed to do. So x cannot be 7/3. So coming back over here to write the domain of my function, x can't be 1 and it can't be 7/3. So here's 1. So I remove that by placing an open circle, and I find 7/3, and I place an open circle at 7/3. So I have to know that 7/3 is bigger than 1. And I can use anything less than 1, anything between 7/3 and 1, and anything bigger than 7/3. But I can't use 1, and I can't use 7/3. So to write this as an interval, minus infinity up to 1, and then union 1 to 7/3, and then 7/3 to infinity. And that's my domain. And that's all I have.